All right, ladies and gentlemen, today, page 40, we are looking at the warm-up. I have 4 problems. Page 40. I have 4 problems, and your job is to figure out which one does not belong. In this warm-up, there's a reason that each one of them could not belong to the rest. So I'm going to give you guys about 1 minute of quiet think time. I would love to see you write your responses in your books. Which one doesn't belong? And don't forget to justify and explain.
Which one doesn't belong? We're looking at these 4, right?
Justify and explain.
Which one doesn't belong?
Yes, sir.
And
They're
there
right
might
over
be
there
more
in
than
that little
one.
green
Might be more
basket.
than one. Explain why you think that one doesn't belong. There might be more than one.
Yep, there can be more than one. Which one doesn't belong and why? Feel free to use your dot if you want to write your explanation on your dot. All right. Seth, can you give me one example? Which one doesn't belong and why?
Maybe 3.
And why do you think 3?
It doesn't like that one.
What do you mean? Can you tell me more about that?
You see 1 plus 5 plus 7. So 1 to 2, 7 plus 5.
Okay. Can anyone help him explain what he's thinking there? What does that mean?
I think what he's trying to say is like 5, like 1, 2, and 4 are like the same numbers, but like they just don't have like a plus, minus, and dots and everything.
Okay. Okay. You want to add, sir?
Well, because 5 plus 7, I mean 5 minus 7 is 2, and 7 minus 5 is negative.
Oh, you got it backwards. 5 minus 7 is negative 2? And 7 minus 5 is 2?
No,
Okay.
no, 5 minus 7 is 2, and 7 minus 5 is negative.
I think you got it
7
backwards.
minus 5 is negative 2.
Yes, 7 minus, I just said that, 7
Oh.
7 minus 5 is negative 2.
Okay. 7 minus 5 is 2. 5 minus 7
Oh,
is negative 2. So I think what he was trying to say was because this is negative 2 and this is 2, this is the only equation that does not equal. Did anyone also write number 4 as the one that doesn't belong? Okay. However, is Seth wrong? Is 3 different than the rest?
Yeah.
3 is the only one that gave us an answer. Or is it? 2 is an answer, right? Is it equal to 7 minus 5? So yeah, it is different from 4 because not only does it balance, it's also the only equation that gave us an answer. So how about 1 and 2? Did anybody say 1 or 2 are the ones that don't belong? Okay. There is a reason that 1 or 2 may not belong. I'm going to give you guys 30 seconds to think to yourselves, why would 1 and 2 be one of the answers that didn't belong? When you think you have an answer, give me a signal, raise your hand, let me know. How is one different from all the other problems?
How's one different than
The
all
arrow.
How's two different?
Nice job on the biggest, thank you, girl. It's what? Huh? Oh, it's adding. Are there any other equations that are adding? No. Okay, but that's also the only one that's adding though, right? All right, so if that's the only one that's adding, then how do we know that 2 is different than the rest of the problems? What's happening in 2? I'm behind you. I'm at Josh.
Right, I don't care what it is, it's keep multiplying.
Right, number 2 is multiplying. So, is there any multiplication in any of the other 3 examples? No. So those are all reasons why they could be different. All reasons why they could be different. So, did anyone actually do the math and try to solve it? What is 7 plus 5? 12. So this is 12, and this equals 12. What's 5 times 7? 35. So this is 35, and this is also 35. This is 2 equals 7 minus 5, so this is 2 equals 2. And then I have negative 2 equals positive 2. So did any of them have the same answers? No. Could that also be a reason why they're not alike? Yes. All right. Moving on. Today our focus is how can we analyze equations to determine what types of solutions they will have. So equations have identified solutions. Sometimes they are no solution. Sometimes it is one solution. And sometimes there's a lot more solutions. So we're going to look at some different examples and we're going to talk about how we can determine what kind of an equation it is. So I'm going to give you guys about 90 seconds. And you're going to work in your group. So this is going to be a square up or a partner up, okay? This is a square up or a partner up activity. And I want to hear discussion. I have an equation here. You can use your dot for this one. This is not in your book, so just move your book to the side. You're using your dot. You're discussing with your partners. I want a reason why or a value that will work for t that makes this equation true. Go.
I would like
Kaylin,
to
do you want to move over with probably?
5 is 2t plus 5 is what I write now.
Okay, I just want to know that part.
2t plus 5 is 2t plus 5. Yes, now see if you can solve it. You are. 2t plus 5 equals 2t plus 5. And then
All right, so why
see
don't
if
you
we
sit
can
here?
solve it.
And then, Josh, you work with David? All right, David, you want to move backwards? Or you want me to help you? I just want you guys to be close enough so that you can actually check. Okay? Thank you. Thank you so much.
Solve it.
Oh,
Let's try to figure out. Find a value. We gotta find a value. So what's the first thing you think you would do? Yep, you can do that. To draw a line in the middle. So what do you think you would do now? Okay, well, you're not adding the 2. Why can't you add the? Why can't I add 2x plus 5? Yes, because the variable's there. Perfect. So what can we do instead? Solve for t. That's your variable. What? You gotta find out what t is, but we gotta do something. That's what our goal is. So what would be our first step with the table? You what? I can't hear you. No.
so, already rolling here, so right here is your.
I gotta do something, but I can only do it with like terms. The two t's are like terms in the 5.
Yes, sir. Well, it's not here, but.
I could go minus 2t on both sides, minus 2t on both sides.
Put it down, you can go.
Okay, so now, they would give you 0, right? You're gonna have 0 plus 5.
What number is TB?
So you can put 0x plus 5, whatever, 0.
guess from 67. So what
And
number
then
did you put
now
in
we
there?
gotta subtract 5 from both sides. What do you do if you subtract it from both sides? So we got 0 equals 0. So what did that
Yes, sir?
tell you? It's gonna be something for that.
All right, so how do we feel, guys? You got some answers here? I'm seeing something, and I saw something as I was walking around. And Davion has something written down that I think is really pretty smart. So I'm going to let Davion tell you what he figured out.
I figured out whatever you do, like I said, it's gonna be the same. Like whatever you do.
Okay, and why, what made you come up with that response? Rosalinda, can you tell me why that made sense to you? Because as his partner, you guys had to come up with that together, right?
Yeah.
Okay, so what was your thinking? How do you know it was going to be the same?
The numbers of one of them could be the same to the other side, and you have to do it.
So because both sides are exactly the same, whatever you do here would also be here. Did anybody else figure that out? So what number could I put in for T?
Well, Karen wanted to do one.
Leah said any. Who over here said any? Shikai? Shikai said any. What did you say? You only did one?
Yeah.
Which one did you do?
did
You
the
said
number
one. Which one did you do?
Just
All right,
the
Jade
number
said, what number did you put in, Jade? One. Jade said one worked. So, is there only one number it can be?
No, it could be infinite.
What other number did you guys try? 3? All right, I had somebody try 3. Any other numbers? 8? Nice. 4? 100? Does it matter what number you put in for T? Because they're both equal. How does this look? It's exactly the same on both sides. So what kind of example do you think this is giving us on what kind of solution it's going to have? If it can be any number, this is an infinite solution. So where might you want to write this down? An example maybe in your notes. So the symbol that we use to show infinite solution actually looks like a sideways 8. So infinite solution, you're going to get really excited about doing these. So infinite solution. And how do I know something's going to be an infinite solution? What structure am I paying attention to in the equation? What do we notice about the equation? If it's infinite solution, both sides are going to be exactly the same.
The multiplication stuff.
It doesn't matter if it's multiplying, it doesn't matter if it's dividing. If the equations are the same on both sides, it's going to have infinite solutions. Because any number will work.